Hi guys, welcome to the third session of linear regression. So let's get with it. Okay, so here we would be doing an exercise. Project is what we would be taking up, and we would use Excel to solve a linear regression equation. So the case that we have at hand is we have an historical data of an insurance company. The data contains demographic information and loss incurred by the insurance company. So the insurance companies, any claims that come to them so there's a car insurance company and the claims are related to, car insurance. So any damages that might happen to a vehicle. So those claims are nothing but loss that an insurance company is making. So that loss information is part of this database. And there is some demographic information that has been provided about the customers of this company. The objective is to predict losses for future clients using their demographic information. So we would need to predict losses using the demographic information, which can be used in future clients. When the future clients comes, how can we use to understand and predict the losses for those customers? So let's get started with it. Okay, so here is the database that we have. First is the policy number that the insurance company maintains. This is the unique key and the primary key and the unique identifier. This would not be used as an independent variable for prediction, but that's what this field is about. The next field is age of the customer. So age of the customer is 24 years, 31 years, 56 years. It's mentioned in years. Next field is the years of driving experience that the customer has. So 5 years, 10 years, 37 years, 31 years, and so on and so forth. Next field is the number of vehicles that the customer has. So one, and I can see only one, but I believe there will be more numbers in it. We would analyze each of these. Let's just run past each of the variables first. Next is the gender of the customer. Gender is male, female, what's the gender of the customer. Next is married, single, whether the customer is married or is single. Followed by that is the vehicle age. So what's the age of the vehicle? And lastly is the fuel type. So it's a petrol vehicle or it's a diesel vehicle. So that's denoted by P or D. And then comes your dependent variable, the losses that the company actually made. So $203, $402, $553, and so on and so forth. So these are the losses that the company actually made. So the objective that we have here is we have to use each of these independent variables, and using these independent variables we will have to predict the losses variable in here. What is the actual losses that are there? Okay, so let's get started with it. First step in this linear regression exercise is we need to understand each of the variables that we have. So let's quickly understand easy way to do in Excel is let's put a filter, and in filter let me drop this age down. Age is a discrete value. Okay, so age has a very varied range. So in the filter I can drop down, I can see that it starts from 16, goes all the way up to 70. Okay, next is years of driving experience. Let me use the filter again to understand that. So it starts from 0, goes all the way up to 53 years of experience. Alright, next is number of vehicles. From the visual examination we could see only one, but there are more, 2, 3 and 4. So there are customers who have 2 vehicles, 3 vehicles, and 4 vehicles. Next is gender, male, female. So male or female, both are there. Marital status, married or single. So there are only 2 types of marital status that are there in this data. Vehicle age, how old the vehicle is. So 0 years, recently bought, all the way up to 15 years. And then fuel type should be only 2, P and D, which is, so yes, D and P, diesel and petrol. So these are the only 2 fuel types. Losses also, let's quickly have a look at it. So it's ranged from 13 to 3500. Alright, so let's get started with it. So this is the data that we had. First, what we would do is we would try and understand the correlation for each of these variables to understand which variables are strong, which variables are weak. So let's do that. This exercise is also known as, bivariates kind of an exercise. So let's calculate correlation for each of these. The formula of correlation, what we have learned is Correl. So we're going to use Correl formula, and I'm going to select my age column first, and then losses my dependent column second, and the correlation is negative 0.44. So it's a medium kind of a strength towards a lower end only, but it's a negative strength for sure. So a negative strength is saying that as the age of the customer is increasing, the losses actually reduce, which intuitively also makes sense. Older people might be more responsibly driving, and in turn damaging their car less, and in turn less claims on insurance company, and in turn less losses for insurance company. So it logically also makes sense that older people should be less prone to losses. Next is years of driving experience. So let's use the Correl formula again and select this and select losses. Okay, so very similar correlation value for years of driving experience, and this also points to the same thing. The customers with higher number of years of driving experience are less prone to losses. Makes more sense. A person has spent more time driving a vehicle, is more attuned to driving behavior and less attuned to damages and losses. So it makes sense. It intuitively also makes sense. So what you're noticing here is I'm not only looking at these numbers, I'm also intuitively validating whether the signs are right or not. Strengths I cannot comment on because strengths only data can tell me, but intuitively I can at least say whether it's positive and negative, whether it feels right or doesn't feel right. So that's a very important part of your analytics. You should always use your understanding also about the, your business understanding to understand whether these signs are making sense. Then next is number of vehicles. So let's do the same thing. Okay, so relationship is very weak. So the number of vehicles a customer owned does not define losses. I would have expected at least more vehicles should have defined less losses. Customers more. Sign though is slightly negative, but it's very weak. It's 0.0 kind of a scenario. So it's weak. Okay, gender Correl formula will not work because gender is a categorical variable. It's it's not numeric in nature. And so is the case with married. So we would come back to these variables. Let's finish with our numeric variables for a minute. Next is vehicle age. So while I'm calculating this, I would want you guys to intuitively think what should be the result and outcome of vehicle ages, whether vehicle age should be positively related or negatively related. Okay, if you have thought of your answers, what vehicle age should be positive or negatively related to losses, let's look at the results. A negative relationship. Older vehicle less prone to losses. Why would that be? A newer vehicle more prone to losses. Though a newer vehicle somebody might want to drive more carefully. Why would that be? Though relationship is weaker, it's about a 0.27 only. It's not as higher as 0.44 or something. It's a weaker. The reason behind this is as the vehicle starts getting older, the value of the vehicle starts getting depreciated. So a same amount of damage on a new vehicle is going to cost more than on an older vehicle. So because of the your parts, your accessories, and everything starts getting your value is depreciated. So insurance company has to pay the customer less. Though the customer might be paying the same amount, but the claim of insurance, the percentage of that claim starts reducing because of the depreciation starts coming in as the vehicle age starts increasing. That's the reason why a vehicle age has a negative relationship with losses. Okay, now fuel type is also categorical. So what we're going to do with these categorical variables is we are going to create dummy variables and we are going to make them numeric variables. So let's create the new dummy variable for gender. So let's call it gender underscore dummy, and let's call this married underscore dummy. this one as fuel underscore dummy. Okay, and how I'm gonna code it is I'm gonna code ones and zeros. So if the customer is a male, then call it 1, else call it 0. If the customer is married, then call it 1, married, then call it 1, else call it 0. Okay, and then lastly, if it's a petrol vehicle, P, then call it 1, else call it 0. Alright, now what we have done is we have created dummy variables which are 0 and 1 in nature. Now our Corel formulas will work on these dummy variables. So we're going to use our formulas again. So Corel, I'm going to select gender dummy, and I'm going to say losses. Let's calculate for each of these, then we will discuss the results. Alright, so now we have results for all the categorical variables also. So if you look at fuel type, we coded fuel type petrol as 1 and diesel as 0. So what we are saying is as the fuel type increases with the negative 0.72, losses decreases. So increases here would mean it moves towards 1. 1 would means petrol. So if the vehicle is petrol type, the losses are lower, and if vehicle is diesel type, the losses are higher. Okay, that's a informative sign. You know, I would not have any reasons to attribute to that as of now, but it's a very strong relationship, negative 0.72. So data is very strong in that. Next is married. So what we are saying is ones and zeros. So has a negative relationship. As you know, married dummy moves towards 1, which is married in nature, losses reduces, sign is negative. So which might make sense. Married might mean more responsibility, lesser likely to do damages to the car, lesser likely of losses, which makes sense. So a negative relationship, though relationship is weak. Gender, we coded male as 1 and female as 0. So, and here I do not want to comment anything why would this be, but the relationship is positive 0.18. So this is now what we have as a correlation calculated for each of these. Now what has this told us? This has told us that probably if I hit the cutoff of 0.4, then these three variables are good variables, strong variables of predicting my behavior. So let me shade them by color green. Whereas these other three variables are some mediocre or lower type of variables, and number of vehicles is not contributing anything, it's 0. So now I've graded my variables in terms of their strength to prediction. Now when I run my regression, simple linear regression, I would be able to use a stronger variable to define it. Okay, now let's come to the regression and how we would go about running that regression per se. So first what we would do is so dependent variable y, every scenario is losses. Independent variable x, so let's take fuel type as an independent variable. So let's take fuel type as my independent variable. Then we will calculate intercept, we will calculate slope, and we will calculate r square of this equation. So the intercept can be calculated for fuel type is, the formula for intercept is intercept only in Excel. So intercept, known wise, so it is prompting me to push in known wise. Known wise is the losses, so losses comma known x. Known x is the dummy variable of fuel type that we have created, known x. So the intercept is 720. Okay, since it's a negative relationship, we are going to get a slope which is negative in nature. So slope formula is linest, L-I-N-E-S-T. Linest is asking me for known y's, so known y's is this. Known x's is this. Constant is nothing but intercept, which we have just calculated. Stats, you can let it leave empty and you can just hit enter. And the slope is negative 42. Now let's calculate r square also. R SQ. Known y's and known x's. So known y's is this, comma known x's. R square is 0.52. It's somewhere between a medium kind of a strength. Now what we are saying is, now we have the equation. If my losses was my dependent variable y, fuel type was an independent variable x, then I have the intercept beta naught and my beta 1 slope against it. Now if I have to write that predicted equation here, let me insert a new column for putting in the predictions. If I have to write that predicted losses, then I can write my equation, which is predicted losses nothing but y equal to intercept. So let's freeze this intercept here. Plus beta 1 slope. So let's freeze our slope also, as a product of my independent variable, which is my fuel dummy. So beta naught plus beta 1 into x is what my predicted losses is, and my predicted value is. So I can drop this down. These are my predicted values, predicted losses when I use fuel type as my independent variable. Now let's calculate the error term that we may have. Okay, let's reduce the size. So actual minus my prediction is my error. So first error is negative 84. Let's drop this down. So these are now my error values. Now let me show you another thing. Let me compute sum of errors here. So as you can see, the sum of errors is 0. So this is the first condition that satisfies that errors summation across all values turns out to be 0, is what we discussed in the previous session. Now let me calculate the squared sum of errors. So squared errors nothing but this raised to the power of 2. Okay, now let's sum this up. Sum squared errors. Okay, so here we have the value for our sum of squared errors. As you can see, this value is very huge and we cannot make any sense out of this value, that what does this value signifies and all. The one transformation of sum of squared errors is what r square is what we saw in the previous lecture. That r square of 0.52 I can see and say, okay, there is some relationship. The relationship looks weak, but there is some relationship. So that's the benefit of looking at r squares and sum of error squares. Now to give you a better perspective, let's calculate these values for each one of these other variables. So let me do it one for age. So my dependent variable will continue to be the same. My independent variable will change to age. And here my independent variable will change to, let's take another one. Let's say vehicle age. And now let's calculate each of these. Okay, now we have our values computed for all each of these three variables. So the variables that we have selected are for three categories. Fuel type is the strongest variable that we saw in the correlation matrix. Age is the next strongest variable with negative 0.44 correlation, and vehicle age is the fairly weak variable with negative 2.27 kind of a correlation matrix. You can see how R square for each of these three variables is different in nature. The R square for fuel type is highest with 0.52, next age is 0.19, and last is vehicle age with 0.07. And you can see how sum of error squares is fairly high for each of these three. Sum of error squares for this is as high as 1.59, a huge number. Next is next highest, and lowest value is for the fuel type. But looking at the sum of error squares, you would have not made any sense unless you had the comparison of these three in with you. But looking at R square straight away, you would have said 0.07 is too low in R square. The strength of the relationship is very weak in nature, and sum of errors is also not exactly zero. It's very low, but it's not exactly zero for losses. For age and fuel type, it's zero in nature. Slopes for all these three kind of are negative in nature, as shown in correlation also. So this is now what we have is a simple linear regression with us done in Excel. The simple linear regression can take only one independent variable, and Excel does not support multiple linear regression. So in Excel you cannot put more than one independent variable in your regression. That is the reason why next session, when we use SAS as a tool to be able to run multiple linear regression, which will be able to use most of as many independent variables you want to push into. So that's what is about this session is. What I would want you to do is, I would leave this Excel as part of my supplementary material. I would want you guys to do this on your own, so that you get a good understanding about what this is. I would want you guys to do it for remaining three variables: years of driving experience, gender, married, and number of vehicles. So do it for remaining three and see how results come out to be.